We are welcome to another class. Today we want to continue with our discussion on surds, and today we are talking about addition and subtraction of surd. One rule we must remember, or we must put to heart, is whenever we want to add or subtract surd, we do that with like surds, like we said in algebra, like times. Addition of surds, two surds are added together or they are subtracted from each other if they are like surds. They have the same root. For instance, 4 root 2 and 3 root 2 are like surds because this has root 2, this has root 2. But if you have 4 root 2 and we have 2 root 3, they are not like surds because this has root 3 and this has root 2. So if we are to add surds together, they must have like roots. If you are to subtract surds, they must also have like roots. Let's consider some questions here. Let's consider simplify. Simplify 4 root 2 plus 6 root 2. These are like surds because they have the same root. So what do? We just say 4 plus 6 root 2. That will give us 10 root 2. 4 plus 6, 10. Then we bring the root 2 together. Now, let's look at another question. Simplify 3 root 5 minus 7 root 5. This is just like saying 7 minus 3, then this is saying 3 minus 7, then root 5. What does this give us? 3 minus 7 is minus 4, so we have minus 4 root 5. This is the answer. They are like surds, the same root. So we just bring one of the roots out, and then the coefficients of the roots, the integers attached to the root, we do the addition or the subtraction. Let's do that other question. Other questions. 3 root 8 plus root 50. Now this question seems as if they are not like surds, but we simplify further. 3 root 8 is the same thing as 4 times 2, while root 50 is 25 times 2. So they are becoming like. We have root 2 here, we have root 2 here. So what do we do here? What's the square root of 4? That's 2. We bring the 2 out, then you write the remaining 2. What's the square root of 25? 5. We bring the 5 out, then we write 2. So this root 2 is here, root 2 is here. 3 times 2, 6 root 2 plus 5 root 2. What do we have? 6 plus 5 root 2. That gives us 11 root 2. This is the answer. So if we are to add or subtract surd, we must simplify the question to a point that both factor or the factors that we are considering to simplify under the surd must have the same root before we can either add them together or subtract them together. Yet another question. Simplify question 4. Simplify 2 root 27 plus root 75 minus 5 root 12. How do we solve a question like this? We simplify. 27 is the same thing as 9 times 3 plus 75 is the same thing as 25 times 3. Yes, 5 is this 4 times 3. Root 12 is root 4 times 3. Root 75 is root 25 times 3. Root 27 is root 9 times 3. So now we have a particular number that is consistent. We have 3 root 3 here, root 3 here, root 3 here. So we can go ahead to simplify. 2. What's the square root of 9? 3. We bring the 3 out. We leave the root 3. The square root of 25, 5. Then we say 5. The square root of 4 here is 2. Then we leave the root 3. This gives us 2 times 3, 6, root 3, plus 5, root 3, minus 10, root 3. So what do we have? We have 6 plus 5 minus 10, root 3. What does that give us? 6 plus 5 is 11. So we have 11 minus 10, root 3. So that gives us root 3. We cannot say 1 root 3. So root 3 alone shows that it has a coefficient of 1. So this is our answer. We make sure that we simplify to a point that all we have like roots, and then we get our final answer. Let's look at another question. Question 5. Root 12 plus root 3. This looks rather easy. 12 is 4 times 3 plus root 3. What's the square root of 4? That's 2 root 3 plus root 3. This is the coefficient of root 3 is 1. So what do we have? 2 plus 1, 2 plus 1, root 3. That's 3 root 3. This is our answer here. Let's look at another question. Question 6. Root 175 minus 4 root 7. Root 175 minus 4 root 7. When we have a question like this, it shows that we must find a root in this other question that will give us root 7. And what will that be? That should be 25 times 7. 5 times 7, 35 is 3. Remember 3. 7 times 2, 14, plus 3, 17. So, the square root of 25 is 5, root 7, minus 4, root 7. 5 minus 4, root 7. That's root 7. There's no need to write 1. Root 7 already shows us that the coefficient here is 1. Another question, root 99 minus root 44 minus root 11. When we see a question like this, there's something that is recurring. 11. 44 is 4 times 11. 99 is 9 times 11. So we just use 11 that way. 9 times 11 minus 4 times 11 minus root 11. The square root of 9 is 3. The square root of 4 is 2. So what do we have? We have 3 minus 2 minus 1 root 11. 3 minus 2, 1. 1 minus 1 is 0. So we have 0. Because 0 times 0 times anything is 0. So our answer is 0. Another question. 3 root 2 minus root 18. We have to do something to this root 18 so that it gives us root 2. 3 root 2 minus 18 is 9 times 2 is 18. So what do we have? 3 root 2 minus the square root of 9 is 3. So 3 minus 3, 0. So we still have 0 as our answer in this particular question. Another question. Root 2 root 18 minus 3 root 32 plus 4 root 50. That's what we have. How do we simplify this? Let's break it down. 18 is 9 times 2. 32 is 16 times 2. 50 is 25 times 2. So there's a commonality here. 2, 2, root 2, root 2, root 2. So 2, the square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. So we have 6 root 2. 2 times 3 is 6 minus 3 times 4, 12 root 2 plus 4 times 5 is 20 root 2. So we have 6 minus 12 plus 20 root 2. So 6 plus 20, that's 26. So 26 minus 12, that will give us 14 root 2. Another question. Root 125 minus 5 root 20 plus 3 root 20 plus 3 root 80 rather. 80. So how do we solve a question like this? Let's simplify further so that we have a particular number that is recurring. So what do we have here? 3 root 125 minus 5 root 20. Then we have, so this gives us 25 times 5 minus 5, 4 times 5 plus 3. Now this is 5 here recurring, 5 is recurring. So what can we multiply by 5 to give us 80? That's 16 times 5. 5 times 6, 30, 0 remainder, 3. So 16 times 5 will give us this. So 5 root 5 is recurring here, which makes it easy for us to do. 3. The square root of 25 is 5. Find the 5 minus 5. The square root of 4 is 2. The square root of 16 is 4 root 5. So we say 15 root 5 minus 10 root 5 plus 12 root 5. This will give us 15 minus 10 plus 12 all root 5. 15 minus 10 plus 12 root 5. That is to say 15 minus 10 is 5. 5 plus 12, that's 17 root 5. Here we have our answer. Another question. Root 60 minus 375 plus root 135. This 12 times 5, that's 75 times 5. 5 times 5, 25, 5 remainder 2, 5, 35 plus 2, 37. Plus this will be 27 times 5. So what do we do here? We just 3 times 4 times 5 minus 25 times 3 times 5 plus 9 times 3 times 5. This question we have to expand further because this 75 is not a perfect square, 27 is not a perfect square, 12 is not a perfect square. But as we keep simplifying, we got perfect square. 4 is a perfect square. So we have the square root of 4 is 2. the square root of 4 gives us 2. So we say 2 root 15 minus 5 root 15 plus 3 root 15. So we eventually have root 15. So what we have 2 minus 5 plus 3 root 15. 2 minus 5 plus 3 root 15. So 2 minus 5 minus 3 plus 3 is 0. So we have 0 as our answer. Because 2 minus 5 is minus 3 plus 3 is 0. So we have 0 as our final answer here. Let's look at another question. 2 root 135 minus 2 root 60 plus root 15 minus root 240. This is rather a long one. Now we've seen 15 here. 60 is 15 times 4. So we look for what can we multiply by 15 to give us 240, and what can we multiply by 15 to give us 135. But we don't need to bother our head so much. We just simplify gradually. This will be 27 times 3 times 5 rather. 27 times 5. 5 times 7, 35. 3 remainder 35 with 5 remainder 3, 10 will give us 135. Then we say 2 4 times 15, then plus root 15, then minus, we don't need to bother our head so long. Let's just give this answer and say 24 times 10. We will still arrive at our answer. So we have 2, 27 is 9 times 3 times 5. 27 is 9 times 3, so we'll put it here. So 2, we have 4 times 15 plus root 15. Then 24 is the same thing as 3 times 8. So we have 3 times 8 times 5 times 2. 3 times 8 is 24. 10 is 5 times 2. So we've seen 15 here, we've seen 15 here. So we can isolate our root 15. The square root of 9 is 3. So we say 2 times 3 root 15 minus the square root of 4 is 2. So say 2 times 2 root 15 plus 15 minus. Now we have the square root of 2 times 8 is 16. So we have 16 times 15. 2 times 8 is 16. 3 times 5 15. So we have 6 root 15 minus 4 root 15 plus root 15 minus 4 root 15. Because this is the square root of 16 is 4. So we can go ahead and say 6 minus 4 plus 1 minus 4 root 15. 6 minus 4 plus 1 minus 4. So what do we have here? 6 minus 4, that's 2. 2 plus 1, 3. 3 minus 4, that's minus 1. So we have minus 15 root 15 as our answer. So sometimes the number is so bogus, we are wondering what exactly will be the perfect square to multiply what number. So we just simplify gradually like we did in 240. 2 times 24 times 10. Then 24 is also the same thing as 3 times 15. Then 10 is 5 times 2. And then we come gradually like that. And then we have our answer. Let's look at another question. Another question. 6 root 27. 6 plus root 27 plus root 75. So what do we do? 27 is 3 times 9. 3 times 9. Why 75 is 25 times 3. So something is common here. 3 root 3 root 3. Say 6 plus square root of 9 is 3. Square root of 25 is 5. So we collect our like times as it were. We say 6 plus 3 plus 5 root 3. That will give us 6 plus 8 root 3. This will be our answer for this question. Another question. Root 52 minus root 117 plus 4 root 13. Root 13. So, root 53 minus root 117 plus 4 root 13. This question tells us that the unit root we are looking for is root 13. So what can we multiply by 13 that will give us 52? That should be 4. 4 times 3, 12. 4 times 1. So, what are we going to multiply by 13 that will give us 117? That should be 9. 3 times 9, 27. 7 remainder 2. 9 times 1, 9 plus 2, 17. 11. So 4 root 13. So this particular root 13 was a link for us to know that the other numbers should be in root 13. So let's continue. The square root of 4 is 2. So we have 2 root 13 minus 3 root 13 plus 4 root 13. So what do we have? 2 minus 3 plus 4. 2 minus 3 plus 4 root 13. 2 minus 3, that's minus 1. Minus 1 plus 4, that's 3. We could as well say 2 plus 4 minus 3. That's 6 minus 3. That will give us 6 root. 6 minus 3, that's 3 root 13. Root 13. Root 13. So our answer will be 3 root 13. And with these questions, I want to believe that our sword is becoming very familiar, something we can walk around, and the anxieties are going away. Let's look at the final question for today's class. Root 224 minus root 126 minus root 56. 14 times 16 minus 14 times 9 minus 14 times 4. So the square root of 16 is 4 root 14. The square root of 9 is 3 root 14. And the square root of 4 is 2 root 14. Okay, minus. So what do we have? We have 4 minus 3 minus 2 all into root 14. 4 minus 3, that's 4 minus 3, that's 1. So 1 minus 2 root 14. So that's minus 1 root 14. So that's minus root 14. With this, we've come to the end of addition and subtraction of surds. I want to believe it was an interesting one. And in our next class, we'll be going into the multiplication of surds. Meet you in the next class.